Welcome to this complete deep dive into few-shot and zero-shot learning, two powerful machine learning approaches that enable models to generalize with little or no labeled data for new tasks. These techniques are crucial in modern AI, especially where data labeling is expensive, time-consuming, or unavailable. Let's begin by understanding what they are. Few-shot learning is when a model learns to perform a task with only a few training examples. Think of teaching someone to recognize a new object with just one or two photos. Zero-shot learning goes even further. It allows a model to recognize new categories it has never seen before by relying on descriptive information like class names or natural language instructions. Both approaches are essential in low-data environments, or when deploying AI in the real world, where new classes or tasks frequently appear. Let's break down few-shot learning. Few-shot methods rely on meta-learning, learning to learn. Models are trained across many small tasks, so they can adapt quickly to new ones. Popular approaches include prototypical networks, map inputs to an embedding space, and classify based on distance to class prototypes. Matching networks. Compare new samples to support examples using attention. And MAML. Model-agnostic meta-learning. Trains models to adapt with just a few gradient steps. Few-shot learning is widely used in medical diagnosis with few annotated images, wildlife recognition for rare species, and industrial defect detection. Now, zero-shot learning. In zero-shot setups, the model relies on semantic information, like textual descriptions or attributes, to classify unseen categories. For example, given a photo of a zebra and the label zebra described as striped horse-like animal, the model can generalize what to look for, even without zebra examples during training. Large language models like GPT-4 and vision language models like CLIP are naturally strong at zero-shot tasks. They map both text and images into a common embedding space. CLIP is a great example. It was trained on 400 million image-text pairs, enabling it to answer prompts like, "Which image best represents a classroom?" without needing task-specific training. Let's talk architecture. CLIP, image encoder plus text encoder, both mapped to same embedding space, zero-shot classification, input image versus text prompts. Highest similarity wins. Few-shot learning can be implemented using prompt tuning or adapters in LLMs. Let's compare the two. Few-shot needs a few examples per class, often uses fine-tuning or meta-learning. Zero-shot uses language or embeddings to generalize, needs no task-specific labels. Zero-shot is used in content moderation, e.g. flagging new harmful content, multilingual translation without specific language pairs, captioning or visual question answering without labeled training sets. In NLP, prompt-based learning has enabled models like GPT-3 and GPT-4 to do few and zero-shot learning through examples provided in the prompt. Example prompt for few-shot. Here, translate hello to French. A. Bonjour. Q translate goodbye to French. A. Example for zero-shot. Translate to French. Thank you. Tools and frameworks you can use. Hugging Face transformers for few-shot prompting. OpenAI API for zero-shot LLM tasks. PyTorch Lightning for meta-learning with MAML or protonets. CLIP for vision zero-shot applications. Here's a sample Python snippet using OpenAI's GPT API for zero-shot text classification. Import OpenAI response equals OpenAI, chat completion, create, model, GPT-4, messages / role, user, content. Classify this review as positive or negative. I loved the food. Let's summarize. Few shot equals learn from a few labeled examples. Zero shot equals generalize without any labeled examples, used across vision, NLP, and speech, powered by meta-learning, contrastive learning, and prompt tuning. Thanks for watching. Like and subscribe for more explainers, and let us know if you want a hands-on demo using GPT or Clip in a few shot setup.